In this lesson, we're going to cover the definition of the derivative, and this means we can actually find m tangent precisely. Last time we had problems calculating m tangent because we would have to rely on the same formula for m secant, and then we just had to do approximations to get it closer and closer to the value it's going towards. But now there is a way to actually find it precisely. It's called the derivative. The derivative is also defined as f prime of something or your slope at that specific point. In general, this is your definition right here. So f prime of x is your derivative of f, and it's calculated as the limit as h approaches 0 for f of x plus h minus f of x all over h. And when you do this calculation, you're going to get the slope at that specific point. Now let's do an actual example to apply this definition. So if I want to find the derivative of f of x, what I'm actually finding is f prime of x. And we're going to use our definition over here. So this is the limit as h goes to 0. For f of x plus h, we're going to plug x plus h inside here. So that'll be x plus h squared plus 2, and then minus f of x. Make sure you put your brackets in. And this is all over h. In our next step, we want to simplify our numerator. So I'm going to square this as x plus h times x plus h. And then I want to distribute that negative to those two terms. Then we want to collect like terms in our numerator. And we could also factor out an h when we do that. So that's x squared minus x squared, 2 minus 2. And then with those two terms, I'm going to factor out an h. And then you can see we can cross out the h from top and bottom. Okay, so now we can evaluate. H is going to be 0. And finally we get 2x, which is the derivative of f of x. So therefore, f prime of x is 2x. We could also find slope at any specific point because we have the general derivative. All we have to do is plug in our x value in here, and then we'll have that slope at that point. So we're going to calculate f prime of negative 1. That's 2 times negative 1, which is negative 2. So that means our slope is negative 2. Now we're going to use what we found in B to find the equation of the tangent. And our point is given to us. X has to be negative 1, which means I need to find my y value first. So I have the full set of points. So we're going to find y. And I had to plug in x equals negative 1 in that to find my y value. So that's negative 1 squared plus 2. So our y value is going to be 3. That means our point will be negative 1, 3. The other thing we need is our slope, and we found that. And then now we can just put it all together. This is your equation for our line. Like the last lesson, we leave the y2 and x2 alone as our variables, and then we're going to plug in our point for our y1 and x1. So this will be y minus 3. Our slope is negative 2, x minus minus 1, which is x plus 1. And that's it. So for the next question, you could try this on your own right now. So you can just press pause, and then when you're ready to go, just press play again to get the solution. Okay, so for this question, we want to find the tangent line. To do that first, we need to find the slope. So we want to calculate f prime of x, where we had to plug in f of x plus h minus f of x all over h. So you'll do that first, and then after you want to plug in x minus 2 because that's given to you right away. So the less variables we have, the better. Once we get to this stage, we want to find a common denominator so we can combine our fractions in the numerator, and that's how we got this. And then after that, we want to simplify this fraction, and when you do, you can cancel out those h's, and finally you can evaluate our limit, and then you should get -1 over 9. After that, you need to find the full point. You're only given your x value, so you need to find your y value. Should be 1/3, so your point should be 2/3. And then we'll put it all together in our equation of a line. So you should get y minus 1/3 is -1 over 9 times x minus 2 as your equation. We're going to try a similar question, slightly different, but we want to calculate the normal line equation. So normal line is perpendicular to the tangent line and then goes through the point of tangency. We're going to again find the slope first, and once we find the slope, all we need to do is reciprocal it and then negate it. Okay, so we're going to calculate f prime of x using our definition of the derivative. So f of x plus h is going to be the root of x plus h minus f of x all over h. Now, before I continue on, let's plug in the 4 so we can eliminate one of our variables. So really we're finding f prime of 4, which is going to be our actual slope at 4. So this will now be 4 plus h minus the root of 4, which is 2. And then now we're going to use our big bag of tricks that we learned in the last unit. We're going to multiply top and bottom by the conjugate. Then we'll multiply across and simplify. I'm leaving the denominator alone. Okay, so now we are just left with h at the top. You can now see we can cancel the h top and bottom. And then we'll evaluate this limit. So we're left with 1 over root 4 plus 2, which is the same thing as saying 1 over 4. So that is your m tangent. To find the m normal, we're going to do the reciprocal of the m tangent and then negate it. So that's the slope we're going to use. And then we'll take a look at our point. Our x value is 4. We need to find the y value. So I'm going to plug this in to f of x. That's root of 4, which is 2. So our point is 4, 2. Now we can plug this into our equation of a line. So our y is 2, m was -4, and then x is 4. And that's it. So for the next question, go ahead and try to do that, and then when you're ready, just press play to get the solution. Okay, so we want to find the derivative of f of x where it's 1 over x squared. You're going to apply the definition of the derivative, so that would be f of x plus h. after that, you want to simplify the numerator a bit by combining it. You need a common denominator for that. And then you want to simplify the numerator. So that means expanding and then collecting like terms. I also moved the divide by h just to the side as 1 over h, so it doesn't get so messy with, looks like a fraction over a fraction. And then once you do have that, you can simplify it even more by factoring out an h so that we can cancel h top and bottom. And once we cancel h from top and bottom, we can evaluate the limit. So you should get -2 over x cubed. That is your derivative for f prime of x. So you can summarize that as f prime of x is equal to -2 over x cubed. There's also an alternate definition that you might want to consider knowing as well. So this one doesn't have h in it. Instead, we're looking at a point x equals a. So it's f prime of a is equal to the limit as x approaches a of f of x minus f of a over x minus a. So we're going to apply this by doing this example where f of x is equal to the root of x. So that means we have f of x, that's just root x. F of a would be root a all over x minus a. And then we're going to multiply it by its conjugate. Then we'll multiply the numerator. We'll leave the denominator alone. And then now we can just evaluate the limit. And that's it. So therefore, f prime of x is 1 over 2 root x. So just the difference between this definition and the other definition, some functions are easier to differentiate with this definition than the other definition. So it's really up to you which one you want to use. Now I'm just going to go over some notation. I was saying that we could say f prime of x. You could also say y prime, because if you're given y equals, for example, y equals 2x, you can find the derivative and then call it y prime after that. Another way to write it is like this, dy dx, or the derivative of y with respect to x. You can commonly see that as well. You could also have df dx, or the derivative of f with respect to x. And then lastly, d dx of f of x, or the derivative of f at x. So this is all the same thing. You just need to familiarize yourself with the different ways of stating the derivative. So in this very last example for this lesson, I'm going to go over all those different notations. So knowing the derivative of x squared plus 2 is 2x, let's write this into 4 different ways. So we could say y prime is equal to 2x, where y is equal to x squared plus 2. So we can do that. We could also say dy dx is equal to 2x, where again y is equal to x squared plus 2. Now the other notation, we need to state that f is x squared plus 2 first. And then, sorry, I'm using an x here. F of x is equal to x squared plus 2. Then that means df dx is equal to 2x. And then lastly, you could also state d over dx of this entire function, so x squared plus 2 is equal